And welcome back. Yes, now look at all the stuff on this workbench here. This is just a small subset of all the projects I'm working on, and there's probably about 3 or 4, if not more than that, scattered about my workshop. But I just thought I'd give you a quick project update and the things that are working well, things that are not quite so well, or hidden problems that we just never thought of. I mean, who would have thought you could have hidden problems with electronic projects? Nope, never occurred to me. Anyway, first things first then. We're just going to blitz through these just to give you a flavour of the things that are going to come up in the future. So, first of all, the phone or smartphone charger. So this is the app that's on the actual phone, and I haven't touched that in a long time now. Well, all relatively speaking, isn't it, really? I'd like to give a big shout out to PCBWay.com. PCB prototype the easy way. Ordering from their website is easy. Enter your dimensions of the PCB into the little box, choose how many PCBs you want, and then press the quote now. You can then modify all the parameters the way you want your PCB to be made. There are quite a few options. And there are quite a few shipping options too. Choose the one best suited for you. Look at the range of boards they can produce here, and I know from personal experience their boards are really second to none. New users get $5 off their first order. And at this time, PCBWay would like to draw your attention to the fact that they're offering a free gift for their new and old customers. Simply click on this button here and get your free gift. And there's quite a bit of information on here that describes their operations at the moment. So why not try them out now? So this is how it's going to look. If you guys want to download this, I can put this up on my GitHub. If you want to download this to Android devices, be my guest. Remember though that the length of this screen is quite long. I've got a Huawei phone here, Smart P, and I've realised that it's in fact longer than a lot of them. So you might end up scrolling the screen to read this nonsense down here. I'll move this text, just cut it off at that point where the time is, and I'll put it into the about section. I've already got something in the about, just to prove I could put it. So I've put that in the about, but what I'll actually do is reword this and perhaps put that in there as well. But what I'll do is put this up into the GitHub. To download this though, remember you're going to have to allow your phone to download from non-approved sources, i.e. elsewhere than the Play.store. Okay, and all this does is the phone charger app, and also deducts a quarter of a penny from your bank account every hour and sends it to me. What? No? Oh, all right then. I'll exclude that bit of functionality. Damn, that was going to be my pension. Okay, so anyway, self-explanatory. These two slider ones, I'll continue to use my pointer, I think. So this is where it starts charging at. This is where it stops charging at. And then it allows the phone to discharge until it's this point again, and then it charges back up. Now, foolishly, I've let it charge up to 92%. So it's not going to charge at the moment. Let's have a look. No, it's falling down now to the 85% mark. But what it does when it hits the 85, it'll then switch on and charge up again. But there's a little bit of an issue that I've noticed. Yes, they say resistance is futile, but not in this case. So we'll talk about that in just a sec. Now, what else have I got to talk to you about on this rather cluttered workbench? Well, let's have a look at this first. This is a new-ish chip. This is the ATTiny13. What's that? You've never heard of it? No, me neither, actually. Not until I'd been alerted by at least a couple of you last week or the week before, saying this is in fact the replacement, well, sort of replacement to the ATtiny 85 and 13 and all that, right? So basically Microchip decided that they were a bit long in the tooth, and they were going to invent a whole new series of chips. Basically the last 3 digits, or 4 digits in some cases, determine the capabilities of that chip. And it's the 1 and the 0 in the middle that determine which series it is. I know it's all getting a bit confusing, isn't it? But basically this is the 1 series because it's got the 1 in the middle. The 4 means it's got 4K memory, and the 2 means it's got 8 pins. Yeah, I know this. I know. So these chips, which you can just about see through the anti-static bag, they're just standard 8-pin dip chips. Are they dip or are they surface mount? You know, I can't even tell that. Let me just have a closer look. Right, there's one in the palm of my hand, having dropped it 3 times. I'm going to keep it there now, not on my fingertip. Now, the new series of chips are in fact not dip available at all. So they're not dual inline packages. They're all surface mount, which, I don't know, might put some people off, mightn't it? But I guess Microchip took that into account. Whoop, there it goes again. But anyway, it's a standard 8-pin, and the interesting thing about it is that these chips are programmed using the UDPI. What's that? Never heard of it. No, me neither again. Yeah, I know, you guys keep telling me these things. I think, well, I better look into it. UDPI is the universal, no, in fact, it's the wrong way. It's the UPDI, let's get it the right way around. Universal Programming and Debug Interface. And until recently, you couldn't actually program these chips. I've lost it on my workbench, so it is down there. You couldn't actually program these chips very easily, not without, specialist equipment, certainly not from the Arduino IDE. But guess what? Spence Konde, I don't know how to pronounce his name very well. He's developed a new core for this, and he's also, or somebody else has also developed a means to program them. A bit like the SPI method, okay? But there's a special JTAG to UDPI sort of converter. And guess what we use in the middle of that conversion? Yes, an Arduino Uno. So it's just pretty much the same as it always was for us. I haven't got as far as actually doing it yet, because those chips only arrived yesterday. And being surface mount, trying to solder them onto a little tiny dip converter board is tricky. Tricky, he said, in a typical British understatement. So we'll see how far I get with that, but you can tell it's something on the horizon, because not only, it's not the chip itself really that I'm that interested, to be quite honest. I mean, an ATTiny13 is really, it's capable, isn't it? And we all know how it works. I've done a few videos on it, but this chip being UDPI enabled only makes me think, oh, that's something we need to understand as Arduinoites going forward. So that's really where I'm going with that. Great, so that's that bit, and thanks very much for bringing that to my attention. Appreciate it. Right, let's put those away and look at something else. Right, so I've put those away, and this has sort of come into view now. What is that, you say? Oh, it's a dual pot. I can see that. So we've got 2 potentiometers there. I think it's 100k each, all mounted onto this funny old breadboard with a 3.5mm jack converter into dip. So if I pull that out, oh, you might have heard that. That was my audio system going mad. That's probably the input. Yeah, if you can hear a buzzing, that's because this is the input to my audio system. Oh dear, blimey. Right, okay, so what's that doing on there? Well, basically, I got a little bit fed up over the last few months of having to change the volume on my PC by pushing either little icons with my mouse at the most inopportune moment. You're in the middle of doing something and suddenly you want to stop the music, and you have to find it in the Windows thing and click it. So eventually I put it on this thing here. Now this is a Stream Deck. This is the mini Stream Deck, and boy, are they expensive. I didn't buy it. I had a review sample. This was it, and it's great. You can, like, as you can see there, there's media keys that I've programmed in, so I can mute the sound, just like that. So I can turn it up, that one, turn it down. That's to play. Well, I use it for Winamp actually. That's to play. That's the next, and that's to go back to a previous menu set. As you can see there, I've been playing about a few little icons and what they can do. That launches Chrome, for example. I mean, basically they are programmable and customizable keys, and you can get this in a much bigger version, which is exactly what I want, to be honest, but I'm not spending out that sort of money. I'll put a couple of links, and there might have been a couple of pictures there. I'll put the big picture up next to this one so you can just see it, but look at that price. Not cheap, but people, gamers especially, swear by them. Not at them, by them, because they are that good. And this is good. I mean, the way you can create icons like this and do basically what you want. So yeah, so let's go back to my media keys. That's where I normally keep it. So that was okay for a little while, but then I got fed up with having to push one of those keys multiple times to get the volume down or up or whatever. So I thought, you know what, I just want to go back to old school. Yeah, I know. My school was very old, and I'm very old as well. So it is old school. And I just thought, I just want to go back to a standard rotary volume control. Because, it's all very well having digital and you push it, but you never quite know how much it goes down by, and then you overshoot. So I thought, having a infinitely variable volume control, which is what these are, because they are infinitely variable, you can turn them up and down as much as you want, would be preferable to me. So I thought, can I actually do that with my setup? Because what happens is I've got, dare I say the word, Alexa word. I've got one of those. Oh my God, she's sprung into action. I've got one of those up there that can stream music and stuff to my Bluetooth, self-contained Bluetooth, that is then fed into my PC. So that's one source of music that I can have. But of course on my PC, I can also play digital radio, I can play Winamp, all sorts of things, right? So there's two streams here, but I tried it out and it works great. Except, of course, as you can see, it's all connected to wires, isn't it? I thought, don't they make some kind of remote volume control? Oh, look, there we are. Look at that picture. Now, this has got nothing to do with Arduinos, but I think it would be quite interesting to do it, and potentially maybe even link it up to, a home automation system. But let's get the thing working. It hasn't arrived yet. So that's what I'm getting from Banggood, and I thought the price was okay. For what it is, and the reviews seem to state that it does work quite well as a remote volume. But I thought also I'd rather have that Bluetooth input to my PC separately controlled. So I've got two volume controls. So I thought I might splash out a little bit, and I'll give you a clue. If I show you these things here, oh no, one's fallen out. They're delicate, well, reasonably so. So these, which quite frankly, as a child, in days of yore, yes, we did have electricity. Yes, we did have running water. But when I was a child, all radios weren't called radios. They were called radiograms, don't you know? And they had these things, valves we call them in the UK, but in America they call them vacuum tubes, which I suppose we could call them in the UK as well, vacuum tubes or vacuum valves. Bigger than this as well. Some were absolutely ginormous. I remember looking through the grill of my dad's radiogram, tuned to the home service, of course, at all times, but they were much, much bigger than this. Anyway, this is a spare set of valves for a product that I have not received yet from Banggood. I'm hoping I don't get stung by VAT and duty, but we'll wait and see. So that's a little clue for you. All right, I'm giving you enough clues on that. When it arrives, I'll show you. Let's just put those down before I destroy them. Right, okay. Let's talk about then, in all seriousness, the problems I've been having with the phone charger. Not in the design, but more in the execution. So we have my Arduino linked up to a Bluetooth device. So this is my little Bluetooth device, and as you can see, it's flashing every so often, and that means it's connected to my phone at the moment. So the phone is sending out messages every minute via this to the Arduino, and the Arduino is the brains, really. It's going, right, you've told me the battery level is 90, whatever that says, 91, and the maximum I can charge to is that, and the minimum I can charge to that. So I'm therefore either going to switch on the power or not. Okay, so it's the Arduino that does the business. However, when I connected all this up, and as you can see, it's on a piece of strip board at the moment with the most worst soldering I've ever come across in my life, because it was just horrendous doing this, quite frankly. But did it? Yes, I did. Because when I put it on a breadboard, like that white one you can see behind there, the charging current to my phone, as measured by this little device, which I'm going to switch on in 10 seconds time since I've finished the sentence so you can see it in action. It said, yes, I'm charging at about 100 milliamps. I'm thinking, charging at 100 milliamps? How long are you going to take charging my phone? So I disconnected everything and put this yellow cable that you see here directly into the phone charger and the other end into my phone, as it is now. And it says, oh, I'm charging at 1.3 amps. And in fact, if you measure the current into here, most of the time it varies between 1.3 and 600 milliamps. When I put it through this unit, it was like 100, maybe 200. And then on the breadboard, I wiggled a few bits about and it dropped down to 30 milliamps, and then it shot up again to 400 milliamps. I thought, this is a bit nonsense, isn't it? So the problem was that there is resistance in the breadboard. As you can imagine, some cheapy old Chinese stuff like this that costs $2 is not going to have a very good resistance in the normal course of events. When we're building stuff on those breadboards, as I've done for years and years and years, it makes no difference. After all, if you've got a 10k resistor and it's 10k and 2 ohms, who cares? Your circuit doesn't, that's for sure. And, you know, transistors, capacitors, if there's this tiny little resistance in series with that, it doesn't matter. But when you're talking about MOSFET switching on, and we're worried about, you know, sub-ohm resistance. In fact, I think this is a 41599 SI4159 dual MOSFET that I told you about, and then it's on this little decent little module here that you can plug into things. So I've soldered it, sacrificed it really, I suppose you could say, into this Vera board so I could do some circuitry. I discovered that instead of it being sort of 0.04 ohms across there, when it went into that micro socket underneath this black cable, so that was the input in there and output out here, the resistance was huge. It was just ridiculous. And when we're talking, as I say, about sub-ohm resistance through the MOSFET, and then have this massive, relatively speaking, resistance elsewhere, no wonder the current wasn't flowing. Let me just switch this on, you'll see. Right, I've plugged all this in now, and as you can see on this little device here, it tells you the voltage and the charging current. It's charging, and it says 480 milliamps, 500, whatever. It changes a little bit, but basically, I don't think I've ever had it above about 700 milliamps, and that's when I've, you know, wiggled a few connections on here and stuff like that. It's gone down to 420, then it's a 510. So basically the problem is not the circuit, not the APK, the Android package over here, the phone app, nor the Arduino, nothing like that. That's not the problem. The problem is the execution of this circuit. So there's that issue. So I can see that this project might end up without a socket. It might be a hardwired cable at both ends. So the voltage in will be a hardwired USB cable to a USB type A, and this one will be hardwired in here out to a USB micro. And there's just one other thing I've come to know over the last 3-4 weeks, is that this will be fine for a 5-volt input. Right, because I've powered all this circuit from 5 volts, and indeed it powers the Arduino. However, smart chargers these days can go right up to something like 12, 15, even higher voltage. Basically, the phone talks to the charger and goes, yeah, give me more, and it fast charged your phone. So within half an hour, you can go from 0 to absolute full power if you want. Probably not so great for the battery, I would imagine. Fast charging, as they've discovered with electric vehicles, is not great for them. But if you want to, and if you allow that to happen between your phone and the charger, that's exactly what will happen. So it will keep ramping up the voltage and the current until the phone says, okay, that's enough now, let's cut it back down again. Now, of course, that won't work on here because we'll blow up the circuit, won't we? Both the Arduino or Nano, whatever it is I'm going to end up using, and this. So I'd actually have to redesign that circuit for a smart charger to say, right, we want a 5-volt supply at this end just to run the circuitry and let the main power run through the SI4599 MOSFET, the P channel one, from one end, so here, to here. It's only like a switch, isn't it, or a relay or whatever. And the resistance of that is 0.04 ohms or something ridiculously low. So that will not change the charging current. I don't believe the low charging current here is due to that. I think it's down to this socket. Because as I say, when I wiggle this plug about, it can change quite dramatically. And I'm pretty sure it's the socket, not the plug, because that's the plug I use all the time. So, but apart from that, that wouldn't actually stop me completing this project. I'd put it in a box and hardwire the cables and say that's as good as it's going to get now, and that would do me, because the idea is we prevent the phone charging to 100% and being kept there all day long, which is what happened when I'm at this workbench here, or when I used to work for a software house, the phone got put on charge for hours on end, so it got up to 100% and stayed there all day basically until I went home again, and that is not good for a battery, as they're also discovering with electric vehicles. They're discovering lots and lots, so I'm not buying an electric vehicle anytime soon, not until they've sorted all that out. But as I say, I'd still put this into a box, but I need to find out whether that resistance there can be removed by hardwiring that cable, so that the PCB that I eventually design is going to be worthwhile doing, not so I think, oh, I'm only charging 100 milliamps, that's no good. Yeah, we want it. If this got to something like 1 amp, I think, okay, that's fair enough. That's 5 watts. That's about as low as you want to charge at, really. But the fast chargers will go right up to, I think it's 30 watts. That's quite a lot of voltage, quite a lot of amps. So that this circuit, as it stands, would not be suitable. But for standard 5 volts, we're okay. Right, there's just one other thing that I need to talk to you about. Last week, I think it was last week, might have been the week before, can't remember now. I told you about this little ATTiny13 development board. There's the little ATTiny13 in the middle. It was about $7, and I said, is it worth it? And at the end of the day, I said, yeah, it most definitely is worth it. As you can see, I've got things hooked up on this now. But a couple of you brought to my attention that you can get a dip socket version of it. And it does say it's an ATTiny13 development board, even the dip socket version. But I think, can you get narrow dip sockets? I don't think so. I've never seen them in my life. And it looked as wide as an ATtiny85, the dip version, dual inline package, right? So I thought, well, there's only one way to find out. This is on AliExpress, so I've ordered one. Probably take, a month to get to me. But I'm thinking, well, if that is an ATtiny13 they've plugged in there into that dip socket, surely an ATtiny85 would just be 2 seconds to whip one out and put another one in. So we'll see how that goes. Now, an update on this. You do need one of these USB ASP things to program it, not an FTDI. That will not work. You think I'd know that after all the little tiny programming boards I've made, but yeah, I know I'm getting old or tired or both. So this USB ASP, the other way around, USB ASP version 2. There is in fact a higher version now. I think there's a version 3 out actually. I don't know how different it can be, but it is obviously. They're cheap, definitely worth getting, if only to program other things. But certainly this board with the 10-pin cable, you do need one of these, not an FTDI. But it's a doddle to use, as I showed you last week, not an issue. However, Nerd Ralph, otherwise known as Ralph Doncaster, who's been talking to me about my fridge alarm sketch that I challenged myself to put on there. If you remember, I already have a nano inside that detects when my fridge door is open, or has been left open, I should say, and starts a cycle of beeps and louder beeps and eventually goes into super duper alarm mode. And I said, if I can put that on here, then I know that the ATtiny13 is not a brain dead chip. It's a super duper little thing. And after a bit of struggle, I put it all on here, apart from the touch routine. Because I said, there's just no more space now. And Ralph Doncaster said, I've got a touch routine for you, and it takes 40 bytes. So I tried to put it on there. I haven't had any success yet. But what Ralph Doncaster has told me, he says, hey, I've been playing about with your slightly unoptimized code. That's a kind way of saying it's a bit of a mess, frankly. And he says, I've got it down to 300 bytes now. I'm thinking, how can you possibly get that down to 300 bytes? It was like 800 when I left it, wasn't it? 800, 900 bytes. How he got it down to 300? He hasn't sent me the code yet, because I think he's still fiddling. So it's just a no-brainer. And he says the reason I haven't got the touch working is probably because this chip's running too slow. Now, I can't remember. I'm pretty sure I've tried it on an ATtiny85 version of this board. Remember, I desoldered that chip and put an 85 on there, and it worked great. But that could be the reason. It's running too slow at 1.2 meg instead of the full 8 meg, either for the ATtiny85, or the 9.6 meg internal clock of the ATtiny13. So there's a little bit of work for me to do there, but I think Ralph Doncaster is like, he's streets ahead of me in this sort of programming game. Yeah, I know. I'm a .NET C# programmer, right? Not this embedded nonsense. I mean, there's newfangled stuff. Who needs to know it anyway? I know. Now the other thing is, he says you could probably do the touch on the ADC pin. So the second pin down, whatever that is, I can't possibly read that from here. The second pin down, that one there, PB3, which on this board is connected to the ADC, in other words, that variable resistor. He says we can do something with that. And he says, I've got some prototype code, and he's showing me the prototype code. I haven't tried it out yet. I've had no time because I'm busy doing videos and stuff. But he's obviously doing all this stuff, and I reckon that fridge alarm stuff is going to fit in here with bells and whistles if I want it to. It's just amazing. Whether I recognise my code or whether he's in fact rewritten the entire thing from scratch remains to be seen, but I think it's probably likely to be the case. So that will be interesting when it's done as well. And when that dip version comes along, I'll just let you know if it is literally a matter of pulling out the 13 chip, the wide-bodied version of that 13 chip, and putting in an ATtiny 85, or whether I'm about to be bitterly disappointed and find they've actually stuffed in a narrow dip socket, which I've never seen in my life, but doesn't mean they're not available, does it? Right, that's that. What else was there? Let me just consult my list. Right, one thing I didn't tell you about on that phone charger, I replaced the HC06 for an HC05 Bluetooth module. The HC05 module was an absolute to program. It really was. I connected it all up as I should do. Then discovered, of course, that it works in an entirely different way from an HC06, even though I watched my own video on how to do it on the HC06. And it was really weird. You connect it up and you say AT, you type in AT into the serial monitor port and hit enter, and it goes, what? You think, well, what have I done wrong? And you try it again, no, and you change the baud rate, and no, and you do it again, it goes, oh yeah, I'm here. You go, well, why weren't you here 2 minutes ago when I did it? What is going on? And I think the HC05 is just extremely laggy. I think it needs time to sort of boot up properly. Once it's working, it seems to be okay, but quite often I'd say, right, I'm renaming you now to something more meaningful than RSB. Remember, my HC06 was called RSB, my initials, and I thought that's a bit nonsense. So I said, right, HC05, I'm renaming you now Smart Charge. And it goes, no. The actual error message that came up was like error 0. And you go, what does that mean? And you try it again, you try it again, you try it again, and you just think, you know, the sign of madness, according to Albert Einstein, is repeating the same action, expecting a different result each time. So eventually you think, I don't know what's going wrong here. And then suddenly it go, oh, okay. You go, what are you doing, HC05 module? It really was an absolute pain in the rear to program. So I'm thinking of, well, I'm going to keep it because there's a feature on the HC05 that I want for that phone charger sketch, and it isn't, well, okay, it's not absolutely required, but it does make life a lot easier. So I want to keep it, but I think I might have to do a complete video on how to program the HC05, and I might have to buy a newer model to see if they've changed the way that works, because obviously the firmware inside that HC05 determines how it responds to all these AT commands. And somebody said, can't we just use the Arduino to program the HC05 in terms of AT commands initially, you know, changing the baud rate, changing the name, changing anything else you want? And I said, no, not really, because as I've just explained, sometimes it doesn't work. And so your Arduino sketch would run and get totally the wrong response. You know, it's not the right tool. An Arduino sketch is not the right tool to initially set something up. Right, once it's set up, then you can perhaps issue some different AT commands. But AT commands, I hate anyway. Quite honestly, they're from about 1910, aren't they? AT commands, not the thing to use as part of your Arduino. Now let me see what else if I've missed out on anything there. No, that's about it. But I might have to do a complete video on how to program the HC05, because there's little bits of information on the internet, and that one particular web page there, that one there, was an absolute godsend, but even that didn't have the full picture, would you believe? Not for the HC05, which I found via link of a link of a link, you know, it is on the internet. And you go, why didn't anybody else find that out? Why did this chap know about it and nobody else? So yeah, that'll be interesting as well. Okay, now there's all these things going on, okay? As you can see, The route I took for the NHS, that's the National Health Service in Britain, obviously all those all those operations and what do they call it, pre-op assessments have been cancelled for the foreseeable future. I tried to go the private route, they're all stopping it as well, not doing any operations. So unless the surgeon determines that this is now urgent and required to be done because it might actually damage the site permanently in this eye, I'm stuck like this for the foreseeable future. So I'm just keeping my fingers crossed now that he decides, yeah, this does need to be done. He seemed to think it should be done back in January, so we'll just wait and see on that front. Okay, that's it. That's the quick project update, and I didn't have to do any soldering in front of you, thank goodness, because you'd all be laughing. I have got a couple of videos in my backlog about, it's totally different to what we're doing here, nothing like this. It's basic Arduino components. For example, I just finished one off yesterday. It's like the Arduino and the transistor, and it's purely from an Arduino point of view. As you know, a transistor can be used for a multitude of things, right? You know, audio amps, RF amps, spaceships, you name it. But I'm doing those videos, those very basic videos, in less than 15 minutes, and it's squeaked in at sort of 14 minutes and 40 seconds or something. How we use those transistors in an Arduino environment from a sort of beginner's perspective. And if I'm going to carry on, it will be like, you know, MOSFETs, diodes, capacitors, resistors, Ohm's law, that sort of stuff. The sort of basic fundamentals that get skipped a lot, don't they? People follow things like this and put things together without fully understanding what it is they're doing half the time. And eventually they get what's happening on the circuit, but they don't understand why. And when it goes wrong, that's when they're really stumped, because they didn't understand the circuit in the first place. They can't possibly diagnose what's going on. So I'm hoping this very short, the series of short videos will help them understand what's going on a bit more, so that they don't get stumped so often and their project can get off the ground. That's the idea anyway. Cool. Okay. Oh yes, and I called it a name that one of you, no names mentioned, but Andy, you know who you are, suggested calling it, and I've sort of modified that a bit, and it sounds quite, it's cool. I think so anyway. Right. Okay. That's it for today. Thanks very much. Do put your comments down below, and hopefully see you in the not too distant future with another video. Thanks for watching. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.